So we can do a very nice plots with Python. So with PyLab, in IPython itself, we can do a plot. I mean, you don't need. Okay, so IPython, how do I do write this? How to make a plot? So I'll make full screen. So IPython, we say IPython minus minus PyLab, and we give that option. Then both pyplot of matplotlib is imported, as well as NumPy is imported. Now with NumPy, I can do this linspace. So I create 100 data points from 0 to 2π. Okay. By the way, since it is NumPy is already imported, I don't need to put np dot. Okay. So all the functions have the same name as in NumPy. So if you are working with in a file, then you have to say import NumPy as np and then np.py, np.linspace. We don't need that. So y equal to sin x. So now I have two arrays, x and y. I can simply say plot x comma y. I demonstrated it earlier, but you can just say plot x comma y. Semicolon. After that, I can put more statements. So x label, I can put label of the x-axis, which is x. And what is the font size of x? I said size 20. Y label is yx, size font size 20. So this is output. So ignore it. And we can put limits of the x-axis is 0 to 2π, and we can set up a grid. And we can save this file into a test.pdf. Okay, so your file will be saved in the same directory where IPython is running. Okay, now this generates a plot like that. Okay, this grid is giving you the grid, so it makes a mesh. And this is x-axis label, and this is y-axis label, y-axis. Okay, so it's just straightforward. You can do it on IPython window itself. But I want to make a kind of more sophisticated plot, especially for publishing for your reports. So then you need to use I normally put all these things in a file, and for any time I want to make a plot, I need to just change the functions. And okay, then we can just run the same file by in Python for file name, and it will generate things. But you don't know to type all these things, many lines on IPython. So few important points to note is that I need to import a new library, a new module called matplotlib.pyplot. Okay, in IPython with minus pylab option, this is already imported. Okay, but we want to import it in a file. Then you have to use this import matplotlib.pyplot as plt. So plt is my name for this short name. Okay, it's a nickname for this long name of the module. Now I also import RC param. So this for parameter. Okay, and this one thing is to figure can be sized. I can use 5-inch by 3-inch figure. You can change this figure size in a different size you can choose, but you have to use this. I'll show you another way to do this file size more cleanly, but one way to do is with RC param. Now this thing is it's very similar to what we did for IPython, but I'm just going to do another plot. So we create a linspace X array with linspace -1 to 1 with 10 points only. This is only 10 points. Now this is x squared, y, and y1 is x cubed. So I'll plot two functions, y equal to x squared and x cubed. So now since this plot is part of plt, so I'll say plt.plot. Okay, so plot function resides here. So one way option is to say matplotlib.pyplot.plot, but that's too many things to write. So that's why it's a shorthand. And so plt.plot x comma y first two, which we did before, but now I can control the plot. So within quotes you put r dot. So r is read and dot is I'm using dot for the plot, and label. Okay. The label is called legend, which I'm going to show you in the next slide. So we can put the legend inside the plot. So it tells you which plot, which color, which plot is correspond to which function. Now R is not useful here, but if I put a latex things like alpha, beta, then that's useful. Slash alpha, slash beta. So R is for that, and I define. I mean, I tell you why R is used for that kind of things. You can look at the notes. Okay, I will not discuss it here, but this is useful when you have a slash. Now we can do the next function x comma y1. Now this is called line width. So line thickness is 3. It's a thick line. This line thickness is 1 by default. Color is green. Yeah, I'm choosing green color for the line, and a label is x cube. So this is called latex symbol. Huh? So y x superscript 3 means x cube. Okay, you can see that this is going to be looking nicely y equals x cube. Now I can make a horizontal line. So x-axis horizontal line. H is for horizontal. So this horizontal line, and line color is black. Now vertical line also I draw at 0. So x equal to 0, there is a horizontal line, and x equal to, there is a vertical line at y equal to 0. Y equal to 0 line. So we can set the limits for both x and y. So label size I can. So this label, x label and y label. So x and y, and font size is 20. Now I need to say where the legend should be placed. So this is called legend. This is y equal to. So legend sits inside the plot. So to tell you that there are two functions, which one is what? So this is that for y equal to x squared, and this for y equal to x cube. The color is not same because there's a black background. In white background, the color will exactly be the same. Okay. Now, so these are all in LaTeX symbols. So it looks nice. So this looks like maths functions. So you can use the $$ for LaTeX. Now I can see this in the same directory. The name of the file will be plot2d.pdf. Okay. So, and plot show is sometimes when it is going to send this to file called plot2d.pdf, but it will not be shown on your screen. Now that looks slightly disturbing because I want to see what the plot is. So one thing is to, of course, go to the directory and click that plot2d.pdf, but you can just say in Python window itself plot show, plt.show. So it will show on the terminal itself. Okay, so we don't need to go to the file and click. Okay, so this is how we, this is simple code to make the plot, and the color is not true color, but because of black and white background, black background. Few important points as objects of matplotlib. There are two objects. So this is something important to know. So they're called figure object and the axis object. So whole plot, this is called figure object. Okay, and within figure object we have axis objects. Okay, axis is a sub object within object within object. Like you can think of this as a building, and this is like rooms inside the building. Okay, so it will become clear in the okay. So yeah, in a minute it will become clear. So fig is an instantiate. Like if you know object oriented, this is one instance of the object. Or object is a class. It's basically a function, and you have to give a name. You have to instantiate it. Like array. Array is a function, but it's a x equal to array bracket inside the arguments. So x is the instance of the array. One array name is x. Similarly, we create a fig object using this function figure. Okay, figure is part of PLT module, and figure size can be the keyword fig size equal to 5,5. So it's a 5 inch by 5 inch block. Okay, within that I will put my plots. Now I'm going to invoke this axis object. So I'll say that add subplot. So this is fig dot. So this is a fig object. Within that I create 4 sub figures, if you like. or subplots. So AX1 to AX4. So all of them has add subplot 2 comma 2 comma 1. So this number of rows and number of columns, and I have 4. So there are 4 locations, the room numbers we call it. So 1, 2, 3, 4, and it become clear when I show the plot. So therefore 1, 2, 3, 4 like that. And each of this block I can put various plots. So first one is x comma x, second one is x comma x squared, third is x comma x cubed, fourth is x comma x4, and all of them are labeled. Okay. Now let's see. So there's some more things which is there in the notes, but I'm just took part of it to illustrate these two objects. Now we have these 4 figures. Okay. So this y equal to x, y equal to x squared, y equal to x cubed, y equal to x4, and we have x label and y label. This is taken from that from the notes. So you note that I avoided ticks. This for ticks. No ticks for first figure, because it will take the value of ticks from below. So same ticks. So this is 0, 0, this is 0.4, and this is 0.8. So of course, when I wrote the code, I assume this, and the code is written that way. But if I write this ticks here, it doesn't look good. So it's avoid ticks here, 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 here. Okay? So these are fancy things we can do with your code, and matplotlib allows all this.